Hi, I'm Scott Lowe with Actual Tech Media. I'm joined today by Goutham Rao, CTO for Portworx. Goutham, thank you for having us today.
Good morning. Thanks for having me.
So, tell us about some of the trends and things that have been happening that led to the creation of Portworx.
Yeah, so some of these trends, actually, what Portworx is working on have been fairly obvious. In the data center, there's been two tracks, the hardware track and the software track. On the hardware side, there's been a desire to move to commodity servers and commodity networking. And over the past couple of years, with the advances made in 10G and 40G, and also on the server side, the advances made in NVMe and SSD technology, the data center, the modern data center, we kind of know how it's going to look like. It's going to be commodity servers, very Ethernet driven. And that's how people want their hardware fabric to look like. People don't want custom switches and custom SAN and NAS solutions. And that's been on the hardware side. In parallel, on the software side, there's been people have been embracing DevOps a lot more. People want to get more agile in their software development methodologies. Also, architectures are moving more toward a service-oriented architecture. So these two things is essentially what Portworx is taking advantage of. On the software side, as people move toward DevOps and embracing service-oriented architectures, technologies like Linux containers and Docker are an obvious choice. What Portworx is building is the software infrastructure fabric that takes advantages of these two things. The changes that are happening on the hardware side, that is moving toward commodity servers, getting storage from onboard servers as opposed to coming off of a SAN or a NAS, and on the software side, taking advantage of Linux containers. We're building software fabric that will provide a runtime infrastructure solution for this type of a data center.
So when we look at Portworx from an architectural standpoint and how it's going to address all the stuff you just talked about, what does it from a 30,000-foot view look like to the user or to the administrator?
Yeah, to be honest, from a 30,000-foot view, we are very seamless and integrated within your container infrastructure and orchestration fabric. Our goal is to be as invisible as possible. We want to enable cloud-like deployments. What I mean by that is we essentially make it very easy for the ops administrators to be able to manage and provision infrastructure in a very fluid, DevOps-friendly way. To be even more strong about what I'm saying, we want to allow developers and DevOps teams to be able to self-provision programmatically the infrastructure that they need, the storage resources that they need. What we do is we make it very easy for the ops guys to manage their hardware fabric, their disks, their servers. We make it completely seamless. All they're worried about is making sure that the power is on in the data center. We let them know when the drives are failing. They can go in and replace drives, but we're taking care of all of the underlying tiering, block management, storage provisioning to your applications.
You know, one of the hot trends that we've seen all over the place today is this idea of hyperconverged infrastructure, combining storage and compute into a single appliance. What do containers and Portworx specifically look like to someone that's considered hyperconverged infrastructure? And how does it sort of compare and contrast?
Yeah. So whenever there are advances in hardware, it automatically allows us software guys to build software that takes advantage of these advances, and hyperconvergence is obviously one of them. Containers take it one step further because it allows us to get all of the manageability that virtualization would have given, but we get bare metal performance by running your applications directly on these servers and without the overhead of virtualization, and we can take advantages of provisioning infrastructure, storage infrastructure. For example, if there are NVMe on the server that it's running on, we can carve out virtual volumes directly off of those NVMe and SSDs and provide them directly to your application running in a container without any overhead whatsoever. What's more interesting is you can have multiple tenants residing on the same server and not competing for I/O because with software like what Portworx provides, we are aware of provisioning the storage resources to each container, and we know which one's a production container and which one's a development container, and we can do the I/O profiling and tuning at that granularity. So yeah, we take advantage of the hyperconvergence and containers to get that bare metal performance and also the density increase. We can pack a lot more containers on a physical server without using virtualization.
You know, we talk about bare metal, that brings us to a good point. What are some of the other benefits of deploying on bare metal rather than trying to put an abstraction layer in between what you're doing and what the hardware is doing?
The biggest advantages are really density increase, performance increase, and also the ability to spark up these instances very quickly. So if you had to stand up, for example, a Cassandra or a Mongo, if you were to try and run that in a virtual machine environment, just the time to bring it up would be a lot longer. So when you're dealing with microservices, services are typically starting and stopping really fast and at a much larger scale. And so by not having to use virtualization and the overhead that it brings to be able to stand up and bring these services up at high frequency and at, let's call it DevOps speed, that's pretty important.
Goutham, thank you very much for having us today.
You're welcome.